Hey there. So today we'll talk about what is rolling updates and what is meant by rolling deployment model. What is the rolling deployment strategy? We'll see everything about rolling deployment model and strategy, how we do, why we do it, what are the precautions that we should be taking. So let's get started. So in a traditional software upgrade, when we see that an application server is taken down, when any server needs to be updated and tested, and then it is returned to the service. This can result to substantial downtime for the application, especially if unexpected errors or problems force a developer to revert the installation to a previous version. So downtime was one of the major thing, and revert was another major problem in the traditional way. In a rolling deployment, it is a software release strategy that staggers deployment across multiple phases, which usually includes one or more server performing one or more function within a server cluster. Rather than updating all the server or tiers simultaneously, the organization install the updated software package on one server or subset of server at a time. The rolling deployment is used to reduce the application downtime and unforeseen consequences or errors in a software updates. So here we do the updates one by one. So you can see in this diagram, first of all, one VM will get updated and then the other VM will get updated. And at a time, the older and the new VM will remain together. So in a rolling upgrade, only part of the server capacity for an application is offline at a given time. It's not like blue-green deployment or it's not like canary deployment. So it's different. For example, consider a three-tier application comprising front-end, back-end, and database deployed with three models or nodes in each tier. Each of the three front-end application server nodes receives traffic through a load balancer. In a traditional upgrade, the load balancer closes all the application traffic for the servers to go offline and then it does the update. But in case of rolling deployment, the organization takes one of the node in each tier offline with the load balancer configured to direct traffic to the remaining servers still running the proven. Current software version server receives updates and testing. The remaining online server supports the user traffic. So it's not, we don't turn down all those VMs at once in rolling upgrade. It's done one by one. So in this example diagram, you can see first of all one VM, then the second VM, and at last all the three VMs are upgraded. Rolling upgrades incrementally replaces your resources pods with new ones, which are then scheduled on nodes with available resources. Rolling updates are designed to update your workloads without downtime. And these days people are doing that with the help of Kubernetes. So you can see in this diagram, when any service gets updated at a time, one VM gets uploaded with the new code, then another VM and the other VM which is already upgraded gets discarded. And before discarding, we check that whether the new VM is ready or not, and the period between which the we check the older code it needs to be discarded and the new code is running fine. That is called the grace period. So grace period is given so that the traffic which was already there and which was already getting processed by that VM should get completed. So rolling updates allows the following actions: promote an application from one environment to another via container or image updates, roll back to previous versions, and continuous integration and continuous delivery of application with zero downtime. So in a rolling deployment, it is a deployment strategy that slowly moves one server at a time, one pod at a time, which has the previous version and with the new version of an application by completely replacing the infrastructure on which the application is running. For example, in a rolling deployment in Amazon EC3 ECS, container running previous version of the application will be replaced one by one with the container running new version of the application. A rolling deployment is generally faster than a blue-green deployment. However, unlike a blue-green deployment, in a rolling deployment there is no environment isolation between the old and the new application version. This allows rolling deployment to complete more quickly, but also increases the risk and complicates the process of if the deployment fails. So when should we use it? We should use rolling deployment when we need to upgrade uh, slowly and we don't need a downtime. So this technique can be used whenever your application supports running multiple instances with different versions at the same time. This is the simplest technique to implement among the three that will cover. The other two are blue green and the canary deployments, which we'll see in the later parts of the videos in future videos, and should be a good first step towards the zero downtime deployment. So what are the prerequisite for doing this? So we should make sure that the application is stateless by storing state in a external service like a database or a key value store. It should support the current application which you are trying to do the rolling update should support more than one instance of the application running at the same time. You may need to introduce a load balancer and check for potential concurrency issues. It introduces the test to ensure the application is backward and forward compatible. It may be necessary to change code to support extra parameters on database tables and event schema. So this is one of the way that explains how it will be done. So suppose you have three nodes on which you have the older code. So first of all, version first node will be discarded after the new code is uploaded with the new node. And in the third picture, you can see when the two nodes are up, the first two nodes are discarded, and at the last, you can see that when all the three nodes are up, all the three older nodes or pods are discarded. So given an application deployed to production with multiple instances receiving traffic, a rolling update will incrementally update or replace the instance until all of them are running the desired version. The number of instances updated at each stage follows a predetermined rate and eventually reaches to 100%. In order to apply this technique, your application needs to be able to run multiple instances at the same time, potentially with different versions. There must be a load balancer or reverse proxy to distribute the traffic among all of them. Finally, it is necessary to have a method to determine if an instance is healthy and ready for traffic. So how it works? So let's say you have a three instance of the application running on which the traffic is coming. The first step is to stop serving traffic to one of the instance and either update the software or replace it with another instance running the desired version. Once the instance with the new version is created or updated, a simple test is to run to verify the instance is healthy and can start receiving the traffic. When the test passes, the instance is added to the pool of instance serving the traffic. When the process for one instance is complete, the same procedure is executed for the next instance until all of them are running the desired version. Since there are always a few instances running at any given time, current or new, the application is operational all the time and no downtime is experienced. Using Kubernetes to achieve this, we can do so user expects application to be available all the time and developers are expected to deploy new version of the name several times a day. In Kubernetes, this is done with the help of rolling updates. Rolling updates allow deployments update to take place with zero runtime by incrementally updating pod instance with new ones. The new pods will be scheduled on nodes with available resources. In the previous module, we scaled our application to run multiple instances. This is a requirement for performing updates without affecting application availability. By default, the maximum number of pods that can be unavailable during the updates and the maximum number of new pods that can be created is 1. In both the options, we can configure it to either number or percentage of pods. In Kubernetes, updates are versioned and we can update or revert one by one with the help of rolling updates approach or strategy. So thank you so much for watching today's video, and if you think the videos are helpful, do like the video and subscribe to the channel.